Globally, the diabetes landscape is, well, it's immense. We're talking over 537 million people affected right now.
And that number's climbing. Projections suggest maybe 643 million by 2030. That's huge.
It really is. And behind those numbers, it's a daily struggle for so many people, isn't it? Managing blood sugar, worrying about insulin resistance.
Absolutely. That constant vigilance and the very real threat of serious health complications down the line, it's a heavy burden.
Which brings us to why we're doing this deep dive. We're looking at something called GLUT4. You hear whispers about it being a potential, maybe game changer, a glimmer of hope.
That's the idea. This protein, GLUT4, plays a really fundamental role in how our bodies handle sugar. So understanding it better could unlock new ways to manage diabetes.
So we'll explore the latest research on GLUT4, how it works, and importantly, how things like diet and exercise tie into it.
Yeah, and can it really transform lives? That's the big question we're tackling.
Our mission for you, the listener. Let's figure out together if GLUT4 really is the breakthrough we've been hoping for in diabetes management.
Okay, so let's start with the basics. Diabetes, at its heart, is about the body not regulating blood sugar properly.
Right, and there are different types, primarily type 1 and type 2.
Exactly. Type 1, that's an autoimmune thing where the body attacks its own insulin-making cells.
But type 2 is far, far more
Yeah.
common, right? That accounts for the vast majority of these millions of cases.
Overwhelmingly so, around 90–95%. And the core issue there is usually insulin resistance.
Insulin resistance, we hear that term a lot. Can you break down what's actually happening?
Sure. Think of insulin as a key. It unlocks your cells to let glucose, sugar, in from your bloodstream for energy.
Okay.
With insulin resistance, the locks on the cells get, well, stubborn. They don't respond well to the insulin key.
So the sugar can't get in easily.
Precisely. It stays stuck in the bloodstream, leading to high blood sugar levels, hyperglycemia. And when that's chronic, happening all the time, that's where the trouble starts.
Yeah, and trouble is putting it mildly. The potential complications are really severe.
Extremely. Cardiovascular disease is a major one. The risk is significantly higher for people with diabetes. We're talking heart attacks, strokes.
And kidney failure too, right? I read that maybe 1 in 3 people with diabetes might develop kidney disease.
That's correct. It's a huge risk. Plus nerve damage or neuropathy, which can affect feet, hands, digestion.
Leading to numbness, pain, and sometimes even amputations.
Tragically, yes. Poor circulation and nerve damage make injuries harder to heal and infections more likely, sometimes necessitating amputation. And then there's the risk to eyesight diabetic retinopathy.
It paints a stark picture. Let's make it more real. You mentioned individual experiences.
Yeah, the sources give examples, like Sarah, a teacher with type 2. Her whole day is structured around managing her blood sugar, checking levels, aiming for that target range before meals.
What kind of range are we talking about?
Typically aiming for something like 80 to 130 mg/dL when fasting. So her breakfast might be oatmeal with seeds, maybe an egg, very controlled.
And lunch?
Something like a quinoa salad, grilled chicken, lots of veggies, very planned. But even then, a small indulgence, say a piece of cake at a party.
You'd throw everything off.
Exactly. Her sugar could spike up to 200 mg/dL or more. It shows the immense discipline needed. Every single bite matters.
It's constant vigilance. What about exercise? There was another example, John.
Right, John, an accountant. He makes a point of getting a brisk 30-minute walk in most days. He knows it helps.
Aiming for that recommended 150 minutes a week.
Yeah, and he sees the difference in his numbers. But if he misses a few days,
He feels it. His sugar levels creep up.
they do. And exercise isn't just burning calories, it's actively helping his cells take up glucose. But there's a balance.
You mean timing it with meals to avoid blood sugar dropping too low.
Exactly. Hypoglycemia is another risk. It's a constant tightrope walk.
And then you add medications into the mix.
Like metformin, which helps reduce how much glucose the liver makes. But it can have side effects, like nausea for some people.
Or insulin injections, which need really precise dosing and timing.
Very precise. Get it slightly wrong, and you can end up on that blood sugar roller coaster, big swings up and down. It's unpleasant and can be dangerous.
It sounds incredibly taxing, physically, mentally.
And emotionally. Think about the constant monitoring, the food restrictions, the worry about complications. It's no surprise that anxiety and depression rates are significantly higher. One survey suggested around 60%.
Wow, it's a massive impact on quality of life. Okay, so against that backdrop, let's bring in GLUT4, this glimmer of hope.
Right. So GLUT4 stands for glucose transporter type 4. It's a protein found mainly in our muscle and fat cells.
And its job is?
It's basically the cell's doorway for glucose. Its function is to help transport glucose from the bloodstream into the cell.
The glucose gatekeeper analogy, I saw it.
Good one. Once inside the cell, that glucose can be burned for immediate energy or stored away for later use as glycogen, mostly in muscle and liver, or as fat and adipose tissue.
And normally, insulin is what tells these gates to open.
Exactly. When you eat, your blood sugar rises, insulin is released, it binds to receptors on the cell surface.
Like ringing the doorbell.
Kind of. And that signals the GLUT4 proteins, which are usually hanging out inside the cell, to move up to the cell surface, the membrane.
And embed themselves there.
Yes, they embed in the membrane and form these channels, these open gates, allowing glucose to flood in. This brings blood sugar levels back down.
But you mentioned something else triggers it too. In muscle cells.
Ah, yes, that's really important. Muscle contraction itself, like during exercise, can also trigger GLUT4 to move to the surface. This happens independently of insulin.
That sounds like a crucial backup system, especially if insulin isn't working properly.
It absolutely is. But in insulin resistance, the main system, the insulin signaling, starts to fail.
So the doorbell rings, but the message doesn't get through properly.
Pretty much. The signaling pathway is impaired, so fewer GLUT4 transporters make it to the cell surface.
Fewer gates open.
Meaning less glucose gets taken up by the cells, it stays high in the blood, and the body often tries to compensate by pumping out even more insulin.
Which just makes the cells even more resistant over time, a vicious cycle.
Exactly that. It's a core part of the problem in type 2 diabetes.
And there's data showing this GLUT4 difference.
Oh, yes. Studies have shown significantly lower GLUT4 activity, maybe 30, even 50% lower in muscle cells of people with type 2 diabetes compared to healthy individuals.
That's a big difference. It really highlights how important this protein is.
It does. So the thinking is if we can somehow boost GLUT4 function, either make more of it or make it work better.
We could potentially improve glucose uptake, enhance insulin sensitivity, lower blood sugar,
And tackle the root cause of insulin resistance, yes.
which could have benefits beyond diabetes too, like for obesity or metabolic syndrome.
Potentially, yes, because insulin resistance is often a common factor in those conditions as well. Improving GLUT4 could help improve overall metabolic health.
Okay, this is getting really interesting. So the research isn't just identifying the problem, it's looking for solutions targeting GLUT4.
That's right. And some of the most promising approaches involve things we can actually do ourselves, like exercise.
We touch on that exercise, triggering GLUT4 movement without needing insulin.
Yes, and research backs this up strongly. One study found that just a single 45-minute session of moderate cycling could boost GLUT4 activity by around 40%.
40% from one workout.
Yes, and the effect could last for up to 24 hours. It shows the immediate power of physical activity.
That's really motivating. The example of Maria with prediabetes, seeing her blood sugar drop after starting regular jogging, it makes sense now.
It does, and it's not just cardio. Strength training is also beneficial.
How so?
Research suggests resistance training over time can actually increase the amount of GLUT4 protein in your muscles. One study showed about a 25% increase after 12 weeks in people with type 2 diabetes.
So building muscle literally builds more gateways for glucose.
That seems to be the case. Combining aerobic and strength training likely offers the best of both worlds for GLUT4.
And Maria wasn't just exercising, she was eating well too. Diet must play a role.
A huge role. They work together. And fascinatingly, certain foods and nutrients might directly influence GLUT4 expression, basically, telling your body to make more of it.
Really? Like what?
Well, there's evidence suggesting diets rich in polyphenols might help.
Polyphenols. Those are the compounds in things like berries, dark chocolate, green tea.
Exactly. One study indicated these could help upregulate GLUT4 expression, particularly in fat cells. So, that Greek yogurt with berries for breakfast.
Might be doing more than just tasting good.
It might be actively helping your glucose gates. Then there's the type of carbohydrate.
You mean low glycemic foods?
Yes. Foods that release glucose slowly, avoiding those big insulin spikes. This seems to create a better environment for GLUT4 to function properly.
Like the example of Alex swapping white bread for whole grain rye and seeing more stable blood sugar.
Right, and some research linked sticking to a low glycemic diet over several months with an increase in GLUT4 expression, maybe around 15%.
Okay, so polyphenols, low GI foods, anything else?
Omega-3 fatty acids look promising too. Found in fatty fish like salmon, walnuts, flax seeds.
What do they do for GLUT4?
Research suggests they can enhance GLUT4 activity, specifically its movement to the cell surface. One trial showed about a 20% increase after 8 weeks of daily omega-3 intake.
So Alex adding flax seeds to his smoothie wasn't just for fiber.
It could be directly helping his GLUT4 work better.
These lifestyle approaches sound really powerful. What about medications? Are there drugs being developed to target GLUT4 specifically?
There's research in that area, yes. One study mentioned a compound G4-EC1 that showed promise in animal models.
What did it do?
It seemed to increase GLUT4 activity quite significantly, maybe 35%, leading to lower blood sugar and better insulin sensitivity in those animals.
But that's still early stages, right?
Very early. Needs a lot more testing before we know if it's safe and effective for humans. It's a potential future direction, though.
And do current diabetes medications affect GLUT4 at all? Like metformin?
Yes, actually. Metformin, besides its main actions, also seems to indirectly boost GLUT4 translocation to the muscle cell surface.
By how much?
One study suggested around an 18% increase, so it contributes to metformin's overall effect.
So for someone like Sarah, taking metformin and making those lifestyle changes.
It's likely a combined effect, with both working together to improve her GLUT4 function and blood sugar control.
It's really interesting how these different paths can converge on this one protein. And the benefits aren't just about blood sugar, are they? It could help with complications.
That's a really crucial point. Better GLUT4 function might help protect against those long-term problems.
How?
Well, some research linked higher GLUT4 activity in fat cells with lower levels of inflammation markers. Inflammation plays a big role in heart disease.
Ah, okay. And nerve damage. Neuropathy.
There's some encouraging animal research suggesting that increasing GLUT4 expression in nerve cells might actually reduce neuropathy symptoms.
Wow. That would be incredible if it pans out in humans. So better sugar control and potentially preventing or easing complications.
That's the hope. And as we mentioned, the relevance extends beyond diabetes.
To obesity and metabolic syndrome.
Exactly. Since insulin resistance and GLUT4 dysfunction are often involved there too, studies have linked to lower GLUT4 activity with more fat accumulation.
And interventions that improve GLUT4 seem to help.
Yes. One trial looked at people with metabolic syndrome. A 12-week program combining exercise, like swimming, and a Mediterranean diet led to increased GLUT4 expression and improvements in things like waist size, blood pressure, and blood sugar.
Like the example of Emma, switching Mediterranean lunches, adding swimming, and seeing real health benefits.
It really highlights how lifestyle changes targeting metabolic health, potentially via GLUT4, can have wide-ranging positive effects.
Okay, this is all very promising. Let's make it practical. If someone listening wants to leverage this, wants to enhance their own GLUT4 function, what are some actionable steps based on this research?
Well, definitely prioritizing regular exercise. A mix seems best.
Like
Maybe some brisk walking a few times a week. Add in some strength training, even body weight stuff like squats, lunges, push-ups. Maybe cycling or swimming if that's accessible.
So getting the heart rate up, but also building some muscle.
Precisely. And think about timing. Maybe a small, healthy snack afterwards to refuel,
Yeah.
like an apple with almonds or a smoothie with berries and yogurt after a longer session.
And dietary choices. What should people focus on?
Think fiber and polyphenols for breakfast oatmeal with blueberries and walnuts is a great example.
Lunch.
Maybe grilled salmon for omega-3s with quinoa and broccoli for low GI carbs and nutrients.
Dinner.
Baked chicken, sweet potatoes for more slow-release carbs, a big kale salad with olive oil dressing. Nutrient-dense.
And snacks. To avoid sugar spikes, but maybe still boost GLUT4.
Almonds are great. Maybe some green tea, even a small square of very dark chocolate, 85% cocoa or higher for those polyphenols.
It's not just about restriction, but about adding beneficial foods. Are there other lifestyle factors?
Definitely. Sleep is crucial. Getting enough quality sleep, like 7-8 hours, helps maintain insulin sensitivity.
And stress. Does that play a role?
It seems so. Chronic stress can mess with hormones like cortisol, which impacts blood sugar. Practices like yoga or meditation might help.
Oh.
Some research suggests even short daily mindfulness sessions could reduce cortisol and actually improve GLUT4 translocation slightly.
So like John doing his morning yoga before breakfast, that could be helping his blood sugar beyond just the movement.
Potentially, yes. It's about a holistic approach. Exercise, diet, sleep, stress management, they all interconnect.
It sounds really positive, but there must be challenges, right? Can't be that simple.
No, it's not simple. For those potential drugs like G4-ACT1, the path through clinical trials is long, expensive, and uncertain. Rigorous testing is needed.
And the lifestyle changes.
They require consistency, which can be hard. Access is another issue. Time for exercise, the cost of fresh, healthy foods, finding safe places to be active. These are real barriers for many people.
So future research needs to think about accessibility.
Absolutely. Finding scalable solutions, maybe effective, affordable supplements that support GLUT4. Community programs offering exercise resources and nutrition support, making it easier for people to adopt these changes.
And exploring GLET4's role in other areas. You mentioned brain health.
Yes, there's growing interest in the link between insulin resistance in the brain and conditions like Alzheimer's. Understanding GLET4's function there could open up entirely new therapeutic avenues down the road.
So wrapping this up, the research around GLUT4 really does offer a significant pathway to hope, doesn't it?
I think so. It provides a clear biological target that explains why things like exercise and certain diets are so beneficial for blood sugar control and insulin sensitivity.
It's not just about managing symptoms, but potentially addressing a core mechanism.
Exactly. Enhancing GLUT4, whether through lifestyle or future therapies, could fundamentally change diabetes management, reducing blood sugar, improving sensitivity, and maybe even preventing those devastating complications.
And the impact stretches to related conditions like obesity and metabolic syndrome, too.
It points towards a more integrated approach to metabolic health overall.
The key takeaway feels quite empowering. While new drugs are hopefully on the horizon, there are concrete things people can do now focusing on exercise, choosing specific beneficial foods, managing sleep and stress that could potentially enhance their own GLUT4 function.
Yes, these lifestyle changes offer a way to take some control, improve quality of life, and lower the risks associated with these conditions.
And the ongoing research promises even more insights, potentially revolutionizing care in the future.
It's a very active and exciting field.
It really is. So for everyone listening, having heard all this about GLUT4, the gatekeepers, and how diet, exercise, stress, and maybe future treatments interact with it, what's one thing that stands out to you personally? Is there one strategy or area discussed today that you might think about exploring a bit more in your own life?